Welcome. In this video series, we'll present a brief introduction to the Generic Carbon Budget Model, or GCBM, developed by the Carbon Accounting Team at Natural Resources Canada, Canadian Forest Service, in collaboration with Moja Global. Displayed here is an overview of the topics that will be covered in this video series, including an explanation of the Full Lands Integration Tool, or FLINT, the modular structure of the FLINT, the structure of a GCBM project including data requirements, tools and workflows, an overview of the GCBM sample project, and we'll conclude with a discussion of troubleshooting and tips. The FLINT is an open source tool developed by Moja Global that for the first time gives countries the ability to build and run advanced monitoring, reporting, and verification systems quickly and efficiently, and the GCBM is an open source model that operates on the FLINT platform. The objectives of this series of training videos are to help new GCBM users understand the data requirements of the GCBM, evaluate the suitability of the model for their forest carbon modeling projects, and learn how to use the model by going through the process of creating and simulating an example project while demonstrating how to make some basic customizations. As previously mentioned, the FLINT uses an open source modeling framework that provides infrastructure to read both spatial and aspatial data, call event-driven modules, generate spatial and tabular output, and log errors and other information. This structure also allows users of the FLINT to focus development on FLINT modules of their specific scientific interest as opposed to framework development. Moja Global is a nonprofit organization that manages the open source aspects of the FLINT, including governance, repository access, etc. Most of the open source code is under Mozilla Public License 2.0. It is free to use, including commercially, for modification and distribution. However, any modified MPL code must remain in the public domain and be available to the user community. Displayed here is a link to view the details of the MPL 2.0 license. Through Moja Global, the FLINT was developed by the Mullion Group, an Australian consultancy company that developed a commercial version of the platform called FLINT Pro, which is essentially FLINT software as a service. They provide a managed infrastructure for preparing and running simulations and visualizing results for their clients. The FLINT is modular by design, so anyone can develop and add new modules as external plugin libraries. It is driven by configuration files that specify modules and data for a simulation. The module template has been made available on GitHub at the link displayed, so that new contributors can easily get started in developing new science modules. The FLINT follows an event-driven framework, meaning that all modules subscribe and react to one or more system or simulation lifecycle events. Events include system initialization, beginning of time step, ending of time step, etc. The FLINT is designed to be highly scalable. It simulates each land unit, typically a pixel, one at a time through its whole time series before moving on to the next pixel. It keeps the memory footprint low so that it can be run on ordinary computing hardware like laptops or scaled up to clusters or cloud computing. Since it simulates the pixels independently, it is easy to distribute work to multiple processes or computers. The FLINT is safe, meaning that growth, mortality, and disturbances are modeled as transfers between pools. These transfers can be in proportional or absolute amounts. For example, you could transfer 50% of the carbon from pool A to pool B, or 500 tons of carbon from pool A to pool B. Importantly, the system always preserves mass balance and all fluxes are accounted. In the next video, we'll discuss the modular structure of the FLINT.